Okay, the first one is an environmentally safe trenchless method and tooling package. It's not a machine. It's more of a, it basically takes the same characteristics of horizontal directional drilling, removes the drilling fluid, and uses air as a substitute, and therefore creates an anti-frack-out system. The biggest problems we've encountered over the last several years, of all that y'all know, has been the spills that we've had, the gallons and the countless gallons of bentonite and drilling fluids that have spilled into our wetlands, rivers, and streams. It's just caused a tremendous amount of problems all the way around, and people trying to work around having that problem, from cleanup to remediation and just the impact it causes on the environment, those spills. So the problem here that the Flexbor can solve is it can be a solution to these frack out problems that we're having when traditional HDD crossings are being applied in the ground. I'm going to take you through a little bit of how this works, okay? Because it's very simple, okay? And this is basically a cutting head here, all right? As it's going through the ground, it could be an HDD cutting head, and it's drilling through the ground from the right side of the screen to the left, okay? The difference that we have here, and the reason why this works, is because directional drilling pumps a fluid into the ground. Water, it's a water-based, it could be bentonite, it could be a polymer, it could be whatever the ground calls for, right? They pump it into the ground, and as the tool cuts the ground, it creates a slurry, and it creates a flowable slurry, and they keep pumping more in, and it eventually flows out the way that the hole's being created. Hopefully, okay. But little fissures in the ground above the borehole and fractures in the ground can release those fluids from that borehole to the surface, and then contaminate whatever is up there, streams, wetlands, whatever it is. And so this tool, instead of the fluid going around it and flowing out the back, basically the tool itself gobbles up the ground, okay? And then once it's inside the center of the tool, air is injected through the pilot that we're running, and it blows those cuttings out the back through the drive casing that's rotating the cutting head, as opposed to in the open borehole. Therefore, casing the cuttings and reducing the risk for. This is a picture of the front of a cutting head here, and so you can see these strategic jets that you see there. You can see the air when we mix a little bit of water in it. We can do this dry. We can do this with a little bit of water. But as that tool is forcing itself through the ground, ground's trying to pack in there. Those jetters are blowing it into the center of that barrel to where a big main jet is in there and drives it off the back. This next slide, it really kind of paints a better picture here. So you have a maxi rig out back behind there running a big, large diameter pipe to turn this. And here, previously, they put a 900,000 foot pilot in the ground to the exit side. So they got an air compressor set up on the exit side, pumping air through that pilot back to the face of the tool that you see in the ground. As it goes through the ground, the cuttings go through that pipe and come out the back of the machine, which the next slide will show you. But if you were doing an HDD crossing, right there in that pit would just be full of fluid, and those would be your returns coming out. Hopefully. If you lose those returns, then they're going somewhere. They're going somewhere in the ground, and not likely to be a good scenario. So here, all the cuttings are cased in the drive casing. The cuttings then follow that drive casing all the way back to the machine, where there's a diverter on the front, that green piece on the top of that Kelly up there where that drill head is. All the cuttings are kind of basically diverted out of the drive casing into the hose, and they could be stopped and deal with that another way. So I'm going to, after this slide, we're going to show you a quick video of the Flex tool and how it all comes together, and you'll get a better idea of this. But this quick segment I'm giving you on Flex tool, what it's all about is stopping the spills. So I'm going to say even a previously bored hole that had frack-outs, if a flex tool came through there on a casing phase, where there was a big, large pool of mud or whatever it is fracked out in the ground, as that tool would come back through that pilot hole, it would literally suck up everything in there and divert it out through that cased process. So here's a video, and then I want to talk to you about one other product.
Horizontal directional drilling is used to install a product on a bend radius. With this traditional installation, there are often problems related to environmental disruptions caused from the drilling process. The inadvertent release of drilling fluid has become the biggest threat to traditional directional drilling methods, as countless gallons enter our wetlands, waterways, and backyards, resulting in major cleanups, fines, and shutdowns. The use of the Flexbor method is a proven resolution to inadvertent returns that are associated with horizontal directional drilling because the Flexbor system utilizes casing to carry the cuttings and provides the least path of resistance. Inadvertent return concerns are eliminated. Here we have a horizontal directional drill performing a radius crossing under a waterway. The pilot's established and the Flexbor push reaming process has been chosen. The air compressor and water pump, if needed, is set up on the exit side of the crossing. The output hose is connected to a pulling swivel. A diverter is attached to the drill's spindle. The flex tool is attached to the pilot string, and threaded drive casings are connected. The air compressor and water pump are turned on. The excavator operator on the exit side keeps a small amount of tension on the pilot string during the ream process, keeping the nose of the tool pulled up into the pilot hole. The drill operator starts rotation, and the push reaming begins. Cuttings are carried through the threaded drive casing back to the diverter, where they're ejected. Consecutive drive casing are added until the crossing is complete. The Flexbor method requires a pilot. The pilot serves as a guide for the cutting head and the supply line of air to remove the cuttings from the bore path. If needed, small amounts of water or drilling fluid can be injected into the airstream. The boring operation begins. The water or drilling fluid is turned on first, about 2 gallons per minute per cutting diameter inch, depending on the groundwater content. Next, the air is introduced. In this case, about 1,600 cubic feet per minute between 225 and 275 psi. The air carries the water or drilling fluid to the face of the cutting head. Strategic jet placement in the front of the head keeps the head clean, the cutters cool, and promotes spoil transfer into the body of the cutting tool. Air and spoil bypass is limited by the seal band directly behind the cutters. The main jet deep inside the flex tool barrel creates a vacuum which helps pull material in as it blows the cuttings through the spoil pipe. This is the path of least resistance. The air carries the spoil back to the bore pit and it blows out the side of the diverter, then into a containment pit where it can be removed. It's important to monitor the outlet of the diverter as cuttings can clog and begin to back up into the spoil pipe. This is an example of a guided bore utilizing a 36-inch flex tool to perform the casing phase of the crossing. We begin with the guided pilot already installed on the line and grade of the proposed bore path. The flex bore head is attached to the pilot pipe, and the lead casing is assembled to the auger boring machine. To prepare for the job, the casing is stuffed with flanged drive pipe. A 6-inch to 12-inch ID promotes good air velocity and spoil flow. Bolt-on spring-loaded centralizers can be added to the drive pipe. They support the drive pipe and protect the casing as the cutting head is rotated. This can be beneficial when jacking reinforced concrete, fiberglass pipe, or even coated steel casing. A rigid centralizer is welded to the lead casing to keep the casing centered behind the cutting tool. Consecutive sections are added. The spoil pipe is bolted up on both ends, and then the casing joint is welded. The bore continues until the cutter head reaches the exit pit. The flex tool and the weld-on centralizer are removed. The drive casing is removed, and the crossing is complete.